Let's look at question 10. Consider a random sample of economics PhDs and why is your initial salary. And, uh, and we are interested in explaining the salary based on econometrics grade. Okay, A, B, C are simply A and like the grade from econometrics course. And you could imagine D or E, but uh, I that is too sad if you get D or E. Anyhow, so the difference from the previous question is that here we have three categories, three groups, rather than like male and female. Male and female example had only two, so much easier. But now we are going to consider three. And question A show that the full model is not identified. Uh, as you know, right? You can just show that it's not alpha. A plus B plus C always equals to 1. So it's always if you get A, B and C are 0, if you get B and the others are 0 and C, then the others 0. So always it is 1 0 0 0 1 0 0 0 1. There are only three different groups. So always sum to 1 that causes multicollinearity. Or you may define x this way and calculate expectation of xi prime is not full rank. But in this case, this is not easy because you have 4 by 4 matrix. This is a 4 by 4 matrix, so showing this determinant equals to 0 is not easy. But so I think I'm just satisfied with this answer. Now I ask you to do some tedious algebra. So let me just write them down all here. The first one drops C alpha 20 plus beta 20 AI plus gamma 20 BI plus U2I. And the next one in part C, I drop intercept B30 AI plus gamma 30 BI plus delta 30 CI plus U3I. And D, we are dropping beta. Yi is alpha 40 plus gamma 40B plus delta 40C plus U4I. As I said earlier, I'm writing like I'm using different subscript because those objects may be different. Alpha here and alpha here may be different. Gammas can be different, so I just wanted to show that they could be different. Also, the error terms could be different depending on what variable you are dropping. So that's why I distinguish them by their subscripts. Okay. So what was the question? Show that this is identified. So let's see, like, so it's 8, 1, 2, 3. So 1 is to show its identification, we can just do this way. And let me define mu A is expectation of y given A, those who get A, right? And mu B is expectation of y for the B group, and mu C is expectation of y, C equals to 1, right? So depending on your grade, I'm going to divide you into groups and calculate your initial salaries. From 1, now then, I will calculate this directly using equation 1. From equation 1, you get expectation. Okay, let me rewrite this. Expectation ui given ai equals to 1. So I just plugged in the first equation into here. Then we get this, and it is 1, it is 0, and this is 0. So exogenate assumption should have been stated. I forgot to do that, but it's pretty straightforward. And then you get alpha 2, 0 plus beta 2, 0. Okay. Similarly, I'm going to do the same thing, like expectation of y given b. I will skip the same algebra. It will give you this, and expectation y given ci equals to 1 equals alpha to 0. Sorry. So only using the first equation, I have these results, and then you can show that alpha 2, 0 is mu c, and beta 2, 0 is mu a minus mu c. Gamma 2, 0 is mu b minus mu c. Okay. So by doing this, you are showing that those parameters are identified by, so left hand side are the unknown parameters, and right hand side mu a, mu b, mu c are observed from the data, right? So you can identify them as long as if you identify those mu's. And to do that, actually there is one more thing we have to think about. The probability of each group should be positive, right? If they are positive, we observe someone who get A, someone who get B, someone who gets C, then we can identify those mu, and from those mu, we can also identify the parameters. So that's how we identify them. And also, I want you to note that here, in the first equation, C is dropped, right? So what we drop is C. So as a result, as I keep saying this, intercept takes care of the reference group. The reference group is the dropped group, and the other parameters are interpreted as the difference from the reference group. So beta and gamma are the difference in their wage, like the difference of the expected wage for those who get A from the expected wage of those who get C, right? As you can see. And then you can do the same thing for equation number 2. So mu A equals, equation 2 is actually simpler, because equation 2, we drop 3, excuse me, this should be 3. Equation 2 drops, it's a delta, like this. So it's already over by equation 2. Okay, so because we dropped the intercept, so that means no group is dropped. So each parameter for each group takes care of itself, right? Coefficient of B captures the expected wage for that group. Okay, so beta, A, all identified as long as probability of each group is positive. All 3 groups should have positive probability, some observations. Okay, and then equation 3 should be the same. In equation 3, we are dropping A. So mu A is alpha 4, 0, and mu B should be alpha 4, 0 plus gamma 4, 0, and mu C should be alpha 4, 0 plus delta 4, 0. So identical, symmetric to the second equation. You know how to do that. And as you can see, the gamma, the coefficient of B, is difference from group A, the reference group. And the coefficient of C is difference from, the reference group. So that is the idea. And discuss how they are different. The last question, how they are different. Depending on which variable you are dropping, the interpretation should be different, right? I explained.